Our next speaker will be talking about detecting the log4shell vulnerability using Go. Sorry, Nova, we're alive. What? He's sick? Oh no. Oh, we got a replacement. Yeah? What? What's he gonna talk about? Okay, and yeah. 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 Thank you. So first of all, I want to wish Leo a very get well soon. Next up, we're gonna talk about two hot topics in Go now. First, we have generics, and we also have fuzzing now in Go. What if we just combine them together in one hot new topic talk? Well, Alexey is gonna do that. So let's talk about fuzzing generics.
Hello, FOSDEM. Thanks for having me. My name is Alexey Palazhchenko, and I will tell you about my experience of using two biggest 1.18 features, generics and fuzzing. Several months ago, we started a new project. It's called FerretDB. FerretDB is truly open source alternative for MongoDB. It is a proxy written in Go, of course, which speaks MongoDB protocol but stores data in PostgreSQL. This way, you can have an open source solution with reliable database and also without all the problems of SSPL. So from the very beginning, we started using 1.18, and you may wonder why, because that version is not released yet. And of course, you already know the answer. The two biggest features was generics and fuzzing. And if I show you the relative size of these features, that would be something like that. So we use fuzzing much more than generics currently. But let's talk about generics first. You're probably more interested in that. So originally, the very first version of FerretDB actually did use generics. And that was several months ago. Generics were not as reliable as they are now. And also it wasn't very clear if they should be used there or not. So they did not work for us very good. And we switched back to using interfaces, as we used interfaces for many years before. And some time ago I was preparing to talk about how generics work and why they don't work for us, and I was thinking, okay, let me extract small examples just for the talk into a separate repository, so it would be easier to show to people how they work and how they don't. And FerretDB is quite a large code base already, so in small repository that would be easier to understand. And it turned out so they are not that bad, generics. Like when you extract them into a small, separate, self-contained problem, it becomes much more clear. And also now we understand that we basically did not use them correctly. So now we know how to do that, and maybe we are going to use them in the future. To understand the problem, let me introduce some MongoDB stuff. So you probably heard about BSON. BSON stands for binary JSON. That's a binary serialization format which is used by MongoDB and also by FerretDB. And BSON document is essentially an ordered map, key-value pairs where keys are strings and values any other BSON value, including other documents, of course. And that's a central data structure in FerretDB and also MongoDB. MongoDB commands on protocol level, that's BSON documents. And to know which command is that, we should check the first field of this document. And of course, to have the notion of the first field, it should be ordered map. So how we implement that in Go? Using interfaces, we will do something like that. You probably saw this code many times and wrote it too. So we just define interface with an exported method and then define our own types, which wrap basic types, and implement this method which does nothing. So you may wonder why we have this method, why it's not exported. That's to disallow people to someone else to define types implementing this interface in some other packages. So sometimes that's desirable, sometimes not. In that case, we want all BSON types to be defined in the same package, so the users of this package could not define their own BSON types. That sounds reasonable. But also this method does not do anything useful. Also, there are several linters in Go that allow us to check that once we do, for example, switch type, we switch between different types of BSON type, those linters can check that all types are actually checked, all types are covered by cases. And then implementation of documents look like that. We basically have a map of key value pairs, and you will see that value is any BSON type, so any value that implements this interface. And we have a slice of keys which preserve order. Set method looks as you could expect it to behave. We accept the key is a string and value as BSON type. We check is this value already present in map. If not, we add it into end of keys. So if you add a new key, it's being added to the end in the order. If you set an existing key, it just replaces the value without changing the slice of keys. And we use it like that. So we just call set with string, key, and value. You can see that key here is not wrapped. That's because that's an untyped string constant, and untyped string constant can be automatically converted to string and any string-like type. And now string type is very much like string. But for value, we have to wrap it into BSON type interface. So int implements this interface. So here we have to wrap it explicitly. The problem here is that we have to wrap it. It would be nice to have to use basic types for both key and value, right? Currently, it's not possible with interfaces. And another problem, we can also set a nil value. Sometimes that could be desirable. For example, in BSON actually there is a null value. It can be represented with nil. But we decided to use a separate value for null because nil too much causes too much problems. So it would be nice to disallow that code in compile time to prevent someone accidentally by passing nil to the function. So let's see how the same code will look in generics. So first of all, we define constraint, which looks like an interface but have a list of methods inside. And you can see that this constraint is implemented, you can say, by int, string, or pointer to document. It looks like a kind of like a type union, but it's not, and that's important. And here is a document, and you can see that map value here is any. Any is an empty interface in Go 1.18, so instead of interface and empty square brackets, curly brackets, you can say any. But why we don't BSON type? We don't use BSON type here. Why we introduced all those generics to have compile time safety, but here we use interface which says even less than BSON type on the previous example. The reason for that is that BSON type is constrained, not just an interface. At one particular moment, that could be only one specific type. For example, I can create a document which contains only integers as values, or only strings as a value. But if you want to have documents that contains both of them, I can't use any constraints there. So I have to use any. In fact, that's not that bad, because that's implementation detail, and we can expose all the public functionality of the document type as methods with actually functions with constraint. So inside it will be wrapped into interface, but all outside API will be type checked at the compile time. Okay, let's see how the method for setting value would look like. It looks like almost exactly the same as set method in the previous example. But here we accept additional type parameter of type BSON type, and we call it t, and then we use it in the actual parameter list. So key is a string, now it's a basic type string, not our own type, and value of type t. So the rest of the notation looks the same. Right, so that code actually has one problem. It doesn't compile. And that's because methods cannot have type parameters yet in Go. And for reasons for that is quite interesting. So by definition, interface is just a set of methods. And if your type implements some interface, you can do that by just defining the same methods as an interface. But what if interface contains methods with type parameters? Should you, how a type can implement this interface? By using the same type parameters or any type parameters, which are compatible or not? How that should work? So other than that, methods are just syntax sugar for functions. And Go team for now decided not to have methods at all because it is not clear if interfaces can be implemented by method with type parameters or not. Should be method with type parameters be a part of interfaces at all or not? So for now, they decided that functions are enough, and maybe in the future methods could have type parameters. So we have to use functions. Function looks exactly the same as the previous example, but now we have to pass document as the first argument instead of passing it as the receiver. Other than that, we still pass the type parameter, and we still use the type parameter as a value. So how the usage looks like? Here we call document set function, passing document, and foo is a basic string, and then value is a basic integer. Great. And then second example does not compile because nil is not a part of our BSON type constraint, so it doesn't compile. Awesome. So let's take a look at that function. That function creates a new document. It accepts a number of pairs. You probably see this API pattern somewhere. And then every time this function should check the number of parameters passed. It should check the number of parameters is right, the pairs, not an incorrect number of arguments which do not form a pair. It should check type of arguments, etc., etc. All that done is in runtime. It would be nice to have it to check at compile time, but that's not possible with interfaces. So how we use it? We call a number of function with number of parameters. And again, all these values are wrapped, but we can't do better with interfaces. It is also possible to call this function with invalid number of arguments and also with invalid types. So the key of the document should be string, but here it is integer. Both those cases are not covered at compile time. So how can we do that better with generics? With generics, we can write this function, which accepts single type parameter of value of this field and one key value pair. It returns a document. Error is not possible there, so we don't even return that because invalid number of parameters it is not possible to pass. It is not possible to pass nil there. It is also not possible to pass invalid key type. But what if we want to make a document with two pairs? Unfortunately, there is no yet support for periodic type arguments, so we have to write something like that. We pass two type parameters and then we create two key value pairs. And we want to create document with three pairs, we have to use function like that. Of course, that doesn't look so good, but that's the best we can do right now, unfortunately. Okay, let's take a look at get method. So for interfaces, that's very, very basic method, which just returns a value from the map. And if that map value is not present, the nil is returned. Nil is default zero value for all interfaces. So here it is actually somewhat useful. And also we have to check that the value is the same, has the same type. So we can't check just with basic int, we have to wrap our int into interface. So how that looks in generics? So let's write this function which returns a value. And here we say that, okay, the user should not only use a key, but also should know the type of the field, right? So we convert this return value to the given type. And if the type is not correct, we return a zero value of the type to indicate that this field is not present or type is incorrect. We can return also Boolean value, for example, but for simplicity, let's say we return zero value. That may be not that useful. Again, the problem here is that the caller should know the type. Here we don't assign that to any existing variable, so we have to specify type explicitly. So I don't know how much that's useful. In my practice, interfaces are better in some aspects, worse in others, and generics, of course, the same. Sometimes they solve the problem for us, sometimes they're not. So if you're looking for an easy answer for you, should you use generics or interfaces? Unfortunately, I don't have it. I would say it depends. It depends on your situation, but at least now you know the limitations. There are no methods, and then there are problems with what types you can use and what already works and what not. Okay, let's look into fuzzing. Fuzzing might be much more simply and more interesting. So what is fuzzing? Fuzzing essentially is a testing quick on steroids. And testing quick is a standard Go package that allows you to generate random values. And Fuzzing kind of works like that. It generates random values and passes it to your function. But then it tries to generate good values that increase the chance of your code to hang or crash or panic or take an infinite loop or use a lot of memory, something like that. And it implements it in a way somewhat similar in theory, not in implementation, but in principle, how test coverage works. So it instruments the code and see what code is being executed with what input, and tries to generate better input to increase test coverage. And one important part of FerretDB is MongoDB binary protocol parsing packages, of course. And that's the sweetest spot for fuzzing, because binary parsing is quite complicated. There are a lot of edge cases, a lot of problems you could not just find with basic unit test, because we developers try to test for happy path, and fuzzing could generate inputs that make our parser crash. So actually FerretDB had fuzzing tests even before unit test. They were as that useful. That's because we started by dumping MongoDB protocol packages and writing code to parse them. And we were more interested in getting this right, like not having any crashes. And after that, once we started to understand protocol more, we started writing good unit tests, not just fuzzing tests. But before we talk about fuzzing, let's talk a bit about test-driven tests. So you probably know what that. We just define a test case with a name, with some bytes, expected value, and expected error. And we check it like that. We unmarshal bytes into value and compare that we got the same value by unmarshalling these bytes. And then we marshal v or v2, it doesn't matter because they are the same, to the new slice of bytes and compare that bytes are the same. So that's very basic test for parsing binary data, quite common. And it looks like that. We just iterate over test cases and run our subtest with a name, and name allows us to have nice error message and also do not fail for the first test case, but for each test case that fails individually. So fuzzing looks very similar. We write a fuzz document function which accepts testing f instead of testing t. And you just call f@, with test cases with generated bytes, with bytes from test case. And there is a fuzz function similar to subtest function, but fuzz function, which accepts additional parameter b. And b is generated bytes. So then fuzzing agent stands to generate interesting value based on already provided seed values. And seed values is what you pass to f@. In my case, that data from table tests, and that's also, I think, would be a quite common idiom in the future. And then we do the same. We unmarshal bytes, compare, then marshal them and compare. So what are problems with that approach? First of all, we can unmarshal data, then marshal them back and get different values for bytes. How is that? So first of all, the first slice of bytes may be larger than we needed. So that happens when, for example, you unmarshal some value from a slice of bytes, but some amount of bytes is not read during the unmarshalling process. Let's say you, for example, unmarshal JSON document, and the first byte you got is curly bracket, and second byte is closing curly bracket. So you just read 2 bytes, and you got the full JSON document. And then the rest of bytes generated. So solution there is quite simple. You just unread portion of B should be removed. Once you compare B with B2, on the next step, you compare with the slice of byte which was actually read. And another problem that sometimes 2 different combinations of bytes produce the same result. Again, in the case of JSON, that could be just additional white space. For example, you have a document and you have white space between colon and the field value. And there are no difference from the logic perspective, but bytes on the wire in the memory could be different. And solution for that to use some form of canonization. For example, for JSON, you just call JSON compact and get the canonical version of that representation. Okay, so what are current issues with fuzzing? First of all, there is no support for subtests, unfortunately. You can't call testing frun because it does not exist. In that case, that we can't use the same function for both table-driven tests and fuzzing tests. And they are very similar. In the previous example, you saw that they look very, very similar. It would be nice to be able to iterate over test cases, test them right there, and then pass to fuzzing function, right? But there is no support for subtests, and that means that first test case that fails actually fails the whole test. That's not very helpful. Hopefully, some forms of tests can be introduced in the future. Second problem is that seed values are unnamed, and that means that once we add seed values to the corpus, and then we call the fuzz function on them, and one of them fails, the fail message would say something like, okay, this function fails for seed value number 2. And you have to check all the seed values. And if you load the seed values from the files on disk, for example, not from the code, you have to figure out which seed value was that. Like, it's good if files have distinct names like 1, 2, 3, but if it's hashes, it could be tricky. And I encountered a strange problem, which is not very easily reproducible, but very usable for me, but I wasn't able to reduce it to something small, self-contained bug wrapper. So one thing that fuzzing should detect is hanging tests. But in my case, if I call the fuzzing with gomax proxy sunset, so by default it uses all the cores, just like compilation or running normal tests, it uses all the cores of your processor. Sometimes fuzzing fails with a message saying, okay, for that particular test case, the function hangs, right? And it writes a file on disk and tells you, okay, run this command, go test with this flag to check this particular input. And you run it and it passes. And the only workaround I found that set gomax prox manually to some smaller values than the number of cores you have. So for example, for 20 core machine, I pass 6 and 6 works reliably. If I pass 10, sometimes not. So by default, I set it to twice as little as cores as I have. I will try to reproduce that problem and report it. Maybe it will be fixed before release. But overall, fuzzing is great. By using it, I found a few problems in Go test fuzz itself, and most of them were fixed. And also I found many bugs in FerretDB in parsing code. Like, you can't imagine how wonderful that was. So definitely use it for parsing if you have any parsing in your code, like network protocols, unparsed and trusted input from users, even like if you can trust it, you should verify that and use fuzzing for testing your parsers. And here are some links. I created a separate repository to extract all the information from this talk about generics versus interfaces. There is another repository I want to give a shout out. It's like introduction to generics, starting from the very beginning to the internals and implementation details. There are 2 official tutorials for fuzzing and for generics now on the website, and there is a separate page for fuzzing specifically. And there are links about me and FerretDB project. Go check out us on GitHub, give us a star, and also you can subscribe to me on GitHub and Twitter. Thank you.